Hello, Miss Blaylock here. This is solving quadratics, and I have a worksheet that's accompanying FlexBlock. I'm going to go over number 5 and number 9 from that worksheet using solving by factoring. There's another session on factoring, so if you weren't able to attend that today, there's another one, I think it's tomorrow, during FlexBlock. So this will be a quick overview, but there's some more to factoring other than quadratics. So if you just have quadratic equations you're trying to solve by factoring, always look for a greatest common factor first. So this one is set equal to 0. When I'm solving quadratics, I want it set equal to 0. This one is not set equal to 0, so I will have to do that first. But since this is set equal to 0, I'm going to look for a greatest common factor. Sometimes every term will have a variable when you have like a third-degree polynomial. This one does not, so it's only a quadratic. I'm only looking for a number that goes into every term. So every term is divisible by 6, so I'm going to factor out a 6. When I say I'm factoring it out, that means I'm leaving it on the line and I'm just putting it in front of a set of parentheses. So 6m squared divided by 6 is m squared, minus 6m divided by 6 is negative m, and then negative 72 divided by 6 is negative 12. And this still equals 0. So I'm just going to leave the 6 hanging out here. It's not really going to have any effect on how I solve, so I can kind of ignore it as I factor my quadratic part. But if I was doing all my work correctly, I need to hang on to it out there. So now that m squared has a leading coefficient of 1, that means my parentheses are going to break down to have m in the beginning. There's no other way to multiply to get m squared except for m times m. And then the way this works is you look for the factors of 12 because we have a leading coefficient of 1. So it's really a times c. A is your leading coefficient of your square term, so once it's factored, 1 times c, which would be in this case negative 12, which would be negative 12. So I'm looking for factors of negative 12, so numbers that multiply to 12, yet add to the middle term. So add to the coefficient of the linear term, or our b value in our ax squared plus bx plus c. So factors of 12, I'm looking for, let's see, 1 and 12, 2 and 6, 3 and 4. 3 and 4 are going to give me a coefficient of 1. Because my sign is negative for the constant, that means I need one of each sign. So I'm going to have a negative and a positive. The only way to multiply to negative 12 is to have one of each sign. And I want my sum to be negative, so that would be either negative 3 plus positive 4, which gives me positive 1, or negative 4 plus positive 3, and that would give me negative 1. That's what I want. I want negative 4, positive 3, still equal 0. Then I can keep my 6 out there if you want. Since I'm solving, I take each factor. So now this is factored. I'm going to take each factor and set it equal to 0 using the 0 product property. If this quantity was 0, that would be 6 times 0 times something, gives me 0. Or I'd make this set equal to 0. 6 times something times 0 is going to be 0. So whatever number makes this group 0, whatever number makes that group 0, those are my two solutions. The reason I'm looking for 0 when I'm solving, I'm looking for my x-intercept. Another word for a solution is x-intercept. When I'm on the x-axis, my y value is 0, so that's why you're setting it equal to 0. M minus 4 equals 0, add 4 to both sides, so m equals 4. M plus 3 equals 0, subtract 3 from both sides, so m equals negative 3. My two solutions for this quadratic equation are 4 and negative 3. Now number 9. 7n squared minus 43n equals negative 6. In order to solve, I need to set the equation equal to 0, so I'm just going to add 6 to both sides. So that leaves me with 7n squared minus 43n plus 6 equals 0. Now in this case, there is not a common factor from each term, so I'm going to have to do what I said a moment ago, a times c. So that would be 7 times 6, which is 42. Now I'm looking for the factors of 42 that make 43. Now in this case, I know I have an ending constant of positive 6 and a middle term that's negative. That means I'm going to have both signs that are negative. So I'm looking for the factors of 42. What numbers multiply to 42 yet add to negative 43? Excuse me. So 1 times 42 makes 42, and negative 1 minus 42 makes negative 43. So before I throw the numbers into my factored form, I know know my factors are going to be -1 and -42. I'm going to rewrite this using factoring by grouping. So I keep my first term, 7n squared. Now I split the middle term, minus n, minus 1n, minus 42n, and then plus 6. And then what I do, and it still equals 0, then what I do is I break it into groups. So I'm going to factor by grouping here. First group, second group. What is the greatest common factor in this group? N. So I'm going to have n times 7n minus 1. And then I'm going to take out a negative. And what is my greatest common factor for each group? -6. So that leaves me with 7n minus 1. Positive 6 divided by -6 is -1. And I want my groups to match. And I do have matching groups, 7n minus 1, 7n minus 1. I'm going to factor that out from each part. So I have 7n minus 1. And what's left over is this n minus 6. So now this equals 0. Should have had that equals 0 still. So I've got my 7n minus 1, n minus 6, which is what I was trying to get to, and both signs were negative. And at this point, I'm just going to make sure you can see what I have on the board. And you can. So you set each factor equal to 0. So 7n minus 1 equals 0, and n minus 6 equals 0. So I'm going to add 6 to both sides. I get n equals 6, and I'm going to add 1 to both sides, and I get 7n equals 1. Divide both sides by 7. So n equals 1/7. So my two solutions are n equals 1/7 and n equals 6. Some proper notation is n belongs to the set of 1/7 and 6.